Hello, welcome back to Mr. C's Biology. It's been a while, but I thought because it's nearly Christmas, we should do some Christmas biology. So I've got a couple of things for you today. So let's see what's biological about Christmas. Firstly, let's talk about reindeer. Reindeer are pretty cool, aren't they? And very Christmassy. Think of Rudolph, here's a Christmas star. So the thing about reindeer is that most deer have antlers, but they'll only have antlers in the male, whereas in reindeer they have both male and female antlers. The other thing to note about antlers is they're very different from horns. Horns have living tissue inside them. Horn on a cow, for example, or a bull is going to be there for their whole life. It doesn't shed, it doesn't fall off in different seasons. An antler, however, is dead tissue, a little bit more like a toenail or some hair, and that is going to shed seasonally. So reindeer will have antlers for a season, and they won't have antlers for a season. For males, most male deer have antlers, and the reason for that is for rutting. So they fight with other males to try and compete for the best females during the mating season. Bigger the antlers often depict how strong the reindeer is because they have enough energy to put into building more antlers rather than just keeping themselves alive. Now females don't compete for males in the same way, and so why do they have antlers in reindeer? Well, the clue comes from when they have the antlers. They have the antlers over the winter period, which is when they would be pregnant. And so it's all about defending food and being able to make sure that they have enough resources to maintain a winter pregnancy. This has led some people to speculate that maybe Rudolph was in fact Rudolpha, the female reindeer, because most males will lose their antlers at the start of winter, whereas females will have them over December, even to late December into the spring. However, most reindeers that pull sleds are actually males, and they do have antlers because they are often castrated, and so they've had their testes removed so that their antlers actually stay on a little bit longer, and their cycle of their antlers, shedding them and growing them, becomes a little bit more like a female's, which gives us a hint as to how these antlers are triggered to be lost or triggered to be grown. It's probably hormonal, and we could have guessed that because it's slow, it's long term, and it's in a cycle, and these are clear signs that something is often hormonal. And so Rudolph, although probably male, was also probably castrated if he was pulling a sleigh. Another cool thing about reindeers is that they make a clicking sound as they walk. Now, this is different from a sound that they make on purpose, like a grunt. It's something that just happens every step they take for their entire lives. It starts off quite a quiet noise, and actually in the male reindeer it can be quite loud in the end. And so the reason for this is that then they can keep together as a herd even in a blizzard snowstorm where visibility is really low. So normally you might think, well, how else would you keep together as a herd? Well, you keep your eyes open so you can see, but in a blizzardy snowstorm, you don't want to have your eyes open too much. You might maybe make grunting sounds to be able to let them know where the others are. But actually, to grunt, to open your mouth, make a voluntary sound, they're going to end up losing some heat. It's going to take a bit of effort to make that noise. And so instead, this clicking sound that happens every single step that they walk helps them keep together. It's quiet enough that they're not heard by predators too much, but it's loud enough so that the herd can hear where everyone is. Now, how does this clicking sound come about in the first place? Well, it's about some friction. There's a tendon, and as this tendon slides over a bone in their back legs, then it makes this clicking sound. Now, another thing that people love about Christmas is the food. So I thought I'd just briefly touch on the digestive system and how that will work, specifically when you're eating a mince pie. So there are two things that happen throughout the digestive system in order to get food into your body so it's useful. So the first thing that happens is digestion. So these big food molecules get broken down into smaller food molecules. And secondly, there's absorption. So these smaller food molecules then get taken into the blood. So if we start with a mince pie going into your mouth, it's going to get chewed. That is digestion, physical breaking it down into smaller chunks. It also gets coated in saliva, and that saliva is going to be able to lubricate the food so it can smoothly go through your gut all the way to the end. It's also got some enzymes in. Now, enzymes are a biological catalyst. They speed up the breakdown reaction. In this case, the enzyme in the saliva is called amylase, and it breaks down starch, a big carbohydrate molecule, into sugars, a smaller carbohydrate molecule. In particular, it breaks down starch into maltose. Now, after it's been swallowed, this mince pie is going to travel down the esophagus and into the stomach. The stomach's got plenty of acid inside it. Sometimes we think that acid's to do with breaking it down, but it's not. That's a common misconception. The acid is there to clean the food, to be able to remove any bacteria that might have gathered on the mince pie as it was sat on the edge. And once it's cleaned the food, then there is some enzymes as well, some proteases that break down proteins. See, the names of enzymes are important as well. The first half tells you what it's about. The second half is often A's. So protease is an enzyme that breaks down protein. After the stomach, it goes into the small intestine, and there's a little squiggle of the small intestine first called the duodenum. Now the duodenum is where lots of juices are added to the food. So the pancreas injects more enzymes, some more carbohydrates to break down carbohydrates, some more proteases to break down proteins, and some more lipases to break down lipids or fats. The liver also is playing a key role, and it's releasing some bile. This bile is then stored in the gallbladder, and then it's released into the duodenum so that there's some gall, some bile mixed in with these pancreatic juices as well. Now, bile emulsifies fats. So if you imagine a fat being a big droplet, and then as it gets emulsified, the bile basically splits it into smaller droplets. And then the lipase that's breaking down this fat into different molecules, fatty acids and glycerol, now that can actually get into more places if it's in smaller droplets. So those two things work together to digest fats into fatty acids and glycerol, these small molecules that can be absorbed. Later on in the small intestine, that is where the nutrients get absorbed. After it's been broken down, all the small food molecules can then be absorbed into the bloodstream. It's got lots of villi, these finger-like projections in there to be able to absorb with a large surface area and to be able to get those blood vessels as close to the small food molecules as they can. After we've got rid of all the good nutrients there, then actually there's probably still quite a lot of water left in the mince pie, and so it needs to go into the large intestine, the colon, and the colon is going to be able to absorb all the water just before it leaves the body. After that, it comes around the colon. It's got the ascending, transverse and descending limb, and then it ends up in the rectum, preparing to leave, and it leaves through the anus as feces. That's our scientific word for poo. So hopefully that gave you a little bit of an idea of what's going to happen to your food on Christmas Day when you put it in your mouth, and where it's going to go and how your body is going to get out all the goodness from it. I hope you enjoyed a bit of Christmassy biology today. We'll be back in the next couple of weeks with a few more videos about living things and things that all living things do. Stay tuned, do click subscribe if that sounds interesting, and I'll see you next time. Thanks for watching.